So this is RSA with example. So I'm going to solve a problem on RSA algorithm. So these are the following steps to solve the RSA algorithm. So the first step is take two large prime number P and Q. Large prime numbers because to get better result in order to solve the problem. The second step is calculate the n by multiplying the prime numbers which we had taken in previous step P and Q. Then another step is calculate quotient function which are denoted by phi n, and that is calculated by to subtract 1 from both of the prime numbers and then multiply with each other. And the next step is to calculate the value of e. Here e is the public key which we are calculating. So to calculate e we have to follow two conditions. The first condition is e should be greater than 1 and less than phi n, which is a quotient function. And the second condition is the quotient function phi n and e have a greatest common divisor 1. Okay, so the next step is calculate value of d. Here d is the private key which are calculating using public key. So this is the formula which are used for calculating the d. And then the next is public key, and the next we are done with calculation of public key, and we found e and n. And again the private key also we have calculated, which is d and n. Now the theory part is done. We have calculated the value of public key and private key which are used in encryption and decryption further. So let's take an example. So we are starting from step 1. So in the step 1 we are letting two prime numbers p and q, which will be 3 and 11. And the next step is to calculation of n. So the n is calculated by multiplying the both of the prime numbers with each other, which is 3 into 11 equal to 33. So we are done with calculation of n. So now we are calculating phi n, which is the quotient function. So to calculate the phi n we have to subtract 1 from each of prime numbers and then multiply with each other. So 3 minus 1 into 11 minus 1, so 2 into 10 equal to 20. So again we are done with calculation of quotient function. Now the next step is calculating of value of e. So we discussed before, we have to take e such that it should follow the both of the two conditions which are given. So e should be greater than 1 and less than 20. So in this situation I take e equal to 7, so that 7 is greater than 1 but less than 20, and at the same time we have to check the another condition which is the GCD of phi n and e should be 1. So if we calculate GCD of 20 and 7, then we get 1, because in 20 and 7 there is no common divisor present. So the next step is calculation of value of d. So to calculate d we have to follow some formula. So this is the formula: D conjugate E inverse mod phi n. So here E inverse is, we take E inverse this side, so here is E inverse, so here come ED equal to congruent 1 mod phi n. So now E is calculated in previous steps, which is 7 into D, as it is we write mod phi n. Phi n also we have calculated, which is 20. So what is the value, so what will be the value of D present here, so that the mod of phi n should be 1? So I take 3. If we multiply 7 by 3 and do mod with 20, then we get 1. So here we have calculated the value of D. Now step 6 and 7, we write public key as 7 and 20 and private key as 3 and 20. Now the encryption part come. So to encrypt the message, again we have to follow one formula, which is C equal to m to the power a mod n, where C is a ciphertext and m is a plain text and E is a public key, which are already calculated in previous steps. So we have to let a plain text, which is m, so I let 32, and there is a condition should be followed when we are taking the value of m, which is a plain text. So m should be less than n, and n is also calculated in the previous steps. So again we put these values in our formula. So C equal to 32 to the power E, and E is 7. So 32 to the power 7 mod 33. So here I don't know 32 to the power 7. I need to use calculator to calculate this value, because this is going to be very a big number. So I assume that whatever this value gives we take as x. So now x is our ciphertext, and now we are going to send x as a ciphertext to receiver. Now the decryption part come. So again we have to follow, or we have to use a formula to decrypt our encrypted message. So here formula is m equal to C to the power D mod n, where m is a plain text and C is a ciphertext and D is our private key, which is a receiver's private key. So now the ciphertext is x, which are received at receiver side, and x to the power 3, because 3 is the value of private key of receiver, mod 33. So when we calculate, so again x to the power 3 is going to a number which are not easily calculated manually, it takes more time. So we know that ciphertext is ciphertext value is x, which is a plain text. Now when we decrypt the ciphertext, then it original message comes. So we take original message m equal to 32. So here 32 come. So this is the whole process of calculating or solving problem on RSA algorithm.